Hello, and today we're going to talk about not just pi, but 10 pi. Isn't that right, Scott?
That's right. I'd like to take you out into the solar system and take a look at all the planets together. And this is the credit is due to this guy, Don Barone, who I read this fact in one of Graham Hancock's forums at least 10 years ago, maybe more like 15 years ago. But the discovery really is an amazing one. And so I made this illustration that kind of memorializes it in a way. And so I lined up all of the planets in our solar system and added up all of the equatorial diameters, the mean equatorial diameters. And that ends up being the number at the top, 400,699 kilometers. And then I divided that by the diameter of the Earth, 12756 kilometers. And the ratio is 10 pi to 99.99%. So that's the ratio of all of the planets in our system to our planet. And it doesn't matter if you use kilometers or miles or furlongs or whatever you want to use, because this is a pure ratio and the units drop out. And
It's
you're
pretty
just
high,
left
isn't
with
it?
10
It's
pi.
pretty accurate.
Yeah. I mean, that's super accurate. And it's one of those head scratchers like, wait, why do we have this beautiful mathematical relationship between Earth and all of the other planets in our system? You know, it
Well,
doesn't.
isn't that what we're doing here, Scott? Like we're picking out these head scratchers, to use your term. It's a bit like, why is the moon the exact same size in the sky as the sun from where we're looking at it? Like we just take that for granted. But when you actually think about, hey, wait, what? Hang on. What had to happen for that to happen?
Well, you know what? It's not what you said. It's not. It's only true during a total solar eclipse
Mm.
because yeah, there's a really complicated orbital dynamics there with the moon and the Earth and
Okay, I
the
got you.
sun.
Yeah.
And so, but it all lines up during that moment of the eclipse.
Yeah.
And again, it's like, what are the chances of that? It seems like astronomical odds against it.
Yeah. Totally.
And yet
Totally.
there it is, you know.
Yeah.
And
Yeah.
how many of these
I
do you see until you start wondering about the relationship of consciousness to the visible world? You know,
well,
these
let's
seem to me
just
to be
dig
signatures of
into
consciousness at some level, you know?
Can I just dig into this diagram with you a
Yeah.
little bit, right? Because you're getting like the combined diameters of all the planets in our solar system and just dividing them by the diameter of our Earth, right?
And
And
doing that is a way to find the relationship between the size of our planet and all of the other planets in the system.
yeah,
This is how
yeah,
you just, I want to know what that relationship is. Oh,
yeah.
it's 10 pi.
And
Okay.
why is pi significant? Just while we're here, I mean, I know we've spoken about this before, but I'm fascinated with pi, because for me it's this really mysterious invitation, into the unknown, essentially. And it marries the relationship between the diameter of a circle and the circumference of the circle. And what boggles my mind is pi goes dot 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 forever. It never repeats and it never ends, right? So it is this infinite process. And so like
And
it's a
because it's
deeply
transcendental, it means there's no algebraic solution to it. There's no simple, easy answer to it. And that's why it motivates people to try to find more digits of pi. And the last time I checked, I think we've people have done it out to 30 trillion or 50 trillion digits was the last time I think.
I
It's
know
incredible. People are motivated to keep trying to find the end of it. And
it's so
there is no end.
mysterious. It
There
is
never will be an end. It's kind of a
it's so
fool's errand
mysterious.
in a way. It's sort of like squaring the circle. We know
Yeah,
that you can't exactly square the circle, but that doesn't stop us from trying
yeah.
because there's this fundamental tension between these opposites that we just, as human beings, we want to come to some kind of resolution about that.
Yeah.
And especially with the circle and its diameter, I mean, how much more simple can you get geometrically? That is dead simple. The diameter of a circle
Well,
compared to its circumference.
look at a circle and you just go like, yeah, I get it. The
Yeah.
diameter is just a line that goes across and the circumference is just like, the circle. So I can understand those two principles perfectly. why is it this deep, infinite, mysterious, unending, strange thing going on with what is probably the simplest of all forms? My eye, your
and the
eye.
most perfect of all forms as well, you know?
Yeah,
And yet,
yeah.
and yet, I think the best we can do is just put a label on it and call it, well, folks, we don't really understand pi or this whole concept, but we're just going to label it and call it pi and move on. And
Now
that works, you know,
to
that's
circle back
practical.
to your diagram of
Mhm.
the solar system, like of all the numbers to pop out of the relationship of the combined diameters for it to be pi, I know it's 10 pi, but it's extraordinary. Like it actually, that's just so beautiful, that one, that our solar system has that encoded in it. Like, really, you know, it could be any other number. It could have decided to say, oh, I'll be 10 times 623,
Yeah, why
you know,
wasn't
or
it,
I'll
you know,
be,
27 or, you know, instead of,
yeah,
you know,
but
31.4, you know.
it's pi, you know.
Mhm.
I find that beautiful, I have to say, that that's encoded in the combined diameters.
I think
I
it just,
really
it
do.
adds another layer of appreciation for where we are in the relationship of our planet to this whole system. There seems to be
Yeah,
some kind of mathematical harmony at work there.
you bet. Yeah. Wow.
We'd love to hear what you all think about this in the comments.